Welcome to HamCram2018. You are about to embark on a groundbreaking journey into the world of amateur radio. This class is designed to acquire your technical class license. So sit back, enjoy the ride. Sponsored by PittsField Community TV.
Welcome back, guys. Let's lead into the multi-mode excitement. All right, for your convenience, compactness, and economy is the most modern amateur radio equipment comes in the form of a transceiver. It combines both transmitting and receiving functions in one package. However, many experienced radio amateurs prefer the performance and versatility of separate transmitters and receivers, also known as separates or twins, where the vastly different functions of transmitting and receiving can be thoroughly optimized. Many manufacturers during the golden age of ham radio built only transmitters or receivers, and the typical ham was compelled to put together his station from a variety of special sources or build his own. And there's a nice picture of a newer one. That's really a nice radio too. Your technician class puts you in the mainstream of exciting 2-meter and 440 operation. You can bounce signals off the moon and talk to stations hundreds of miles away off of the meteor trails. This excitement is available to you as a technician operator, but you need more than just a simple FM transceiver. Look for a multi-mode VHF transceiver to get started on the 2-meter band using CW and upper sidebands for weak signal work. There is also a satellite weak signal window between 145/800 and 146 megahertz. It takes a multi-mode radio on the CW and SSB to work weak signals, VHF activities. There's a little diagram for your information signal modulating, unmodulated carriers, amplitude, and frequencies. I'll just hold it there for a little bit. Yeah, let it sink in, and it's all about having fun, guys. So, unlike most common FM modes, you'll be using with your dual band handheld single sideband (SSB). Requires special yet not too expensive equipment, and 6-meter sideband radios are seen regularly at swap meets. Join our Ham Fest, join No Barks. They happen yearly. MIT, stuff like that. So they're all over the place, pretty much all the time during summer. 6-meter SSB signals are ideal for bouncing off the ionosphere, and as you will hear on the enclosed audio CD, it is mighty exciting.
You don't have an enclosed audio CD?
I don't have the CD.
Skip the enclosed audio CD.
Yes. We use frequency modulation through FM repeaters, many UHF, VHF ham bands. But near the bottom of the 6 meters, 2 meters, quarter, 1 1/4, and 432 and 1296 megahertz, we use single sideband, which uses less bandwidth than a regular FM signal. A form of amplitude modulation is called sideband, single sideband, SSB. Remember, it's in red for a reason. With single sideband, signals are the amplitude of the radio waves rises with the spoken word up to the limit of around 2.8 kilohertz. Some hands employ a double sideband, so the radio wave both rises and dips, occupying almost twice as much of the bandwidth as single sideband. Single sideband is the type of modulation we use for weak signal, UHF and VHF, work on technical class frequencies. Okay, so on VHF and UHF, we always use upper sideband. That's kind of important. Everything in red. Excuse me. As our communication mode, single sideband is an advanced feature that you'll have been on the air for a few months in technical class operator. You won't find single sideband capabilities in a ham handheld. You will find SSB in all worldwide high-frequency radio sets. This equipment may also give you 6 meters, 2 meters, and 70 centimeters, in addition to the worldwide HF capabilities. We don't use single sideband through repeaters. The repeaters are usually set to what they are. Single sideband is found on the bottom of the bottommost UHF, VHF ham bands. So you will want to try to use the following frequencies, all upper sideband, to hear some SSB signals. And there's listed 10, 6, 2, and 70. No FM allowed on these weak signal sideband frequencies. World equipment, which includes all of these bands plus HF, costs less than about $1,000. Modulation is the process of applying information, voice, video, or digital, into a radio signal. The information modifies some characteristics of the radio frequency carrier, so the information may be transmitted through the air. Inside that the brand new dual band handheld, is a circuit called a modulator. It converts your spoken word going into the microphone into an electrical speech signal that is combined with an RF carrier. The modulator is always on the transmit side of your equipment, tied into the microphone. So if anybody starts diving into things, when you start pinning a mic, call Josh, because where you plug those pins in and how you solder that wire in could make or break you or your radio. So it's important to make sure that you get everything connected right. A properly adjusted single sideband transmitter on the VHF, UHF frequencies for technical class operator occupies about 2 to 3 kilohertz of bandwidth, depending on your voice characteristics. We employ upper sideband for UHF and VHF weak signal work. For single sideband, the normal voice bandwidth is about 250 hertz, so the 2400 hertz bandwidth selection would be the appropriate filter. This usually happens automatically, so you don't need to do anything, just enjoy the weak signal work. As a new technician, you will be able to, you'll want to explore all that's available to you, and weak signal SSB or CW operation is permitted in at least some portion of all amateur bands above 50 megahertz. Multi-mode VHF transceivers are now plentiful and inexpensive. If you plan to do some weak signal work, that's great. We need more weak signal operators using CW, Morse code, and simple sideband. It will take a little practice to tune in the voice properly on your single sideband, and you should set your RIT or clarifier to the neutral position and then adjust slightly by turning the big knob for proper SSB voice reception. You can then make your fine-tuning adjustments with your receiver RIT or clarifier.
What's RIT stand for? What's RIT stand for? Anyone know?
Receive
Intermittent.
intermittent technology.
I don't know. I'm clueless, I ask. Nobody knows.
Receive is not intermittent, but in small increments. Receive incremental tuning.
Yeah,
Yes.
there you go. Receive incremental tuning.
And that's what takes what sounds like Darth Vader and turns them into R2, and then finally a human being's voice.
Basically what it does, it takes you out back into the fractions of the band that you're on to bring it back in line.
The RIT control is found on the high end of weak signal, mobile, and base operation capable of SSB. The receiver incremental control allows you to fine-tune the receiver slightly up and down, about 1 kilohertz, without changing the transmit frequency, which is useful for working satellite Doppler shifts. For non-satellite work, leave the RIT disabled so you are always transmitting and receiving on the same frequencies. When we speak into the microphone, sound pressure waves strike an element which converts acoustic energy into electrical waves. The electrical waves are then sent along the transmitter that will ultimately transmit electromagnetic or radio waves into the airwaves. Microphone jacks are powered by the connection on the handhelds as well as mobile equipment, and they look similar between different manufacturers, but they are not. Some mobile radios, microphone jacks, output a small DC voltage to power. That's a good one to keep down. The microphone. Each manufacturer assigns this voltage to a specific pin. If you accidentally plug in the wrong microphone, you could short out the voltage to ground, zapping your radio instantly. And it is an expensive fix. All radio signals originate with an oscillator of some sort, somewhere in the circuitry. An oscillator is essentially an amplifier with positive feedback and some frequency determining components. Most frequencies are resonant or a tuned circuit. Oscillators come in countless varieties, using everything from vibrating quartz crystals to wobbling atoms as their resonant circuit. Some of the most classic oscillator circuits are used in amateur radios are Colpitts, the Hartley, and the clap oscillator. Various multi-vibrator circuits are also function as an oscillator-like fashion in many digital circuits. The Federal Communications Commission may soon rule on the switch from restricted types of communications over the more reasonable bandwidth limitations for amateur communications. FM voice and slow scan TV use modest bandwidth. SSB voice has a skinny bandwidth, and the ultra narrowest bandwidth of all of these answers is Morse code, or CW. Even though the code test for CW has been eliminated for all classes of ham, CW will always be a popular ultra-narrow bandwidth way of communicating. I hope all of you will try some CW down the road, and a worldwide portion of the technical class privileges on 80 and 40, 15, and 10 meters. When you switch your multi-mode rig over to CW, you will see that the bandwidth narrows down. This minimizes the pickup of other CW signals off frequency. About 150 hertz is just right. For Morse code, CW would restrict the bandwidth down to a skinny 400 hertz. Anything wider would bring in noise. Again, when you switch your worldwide radio to CW, the narrower 500 hertz bandwidth the filter automatically kicks in. On 6 and 10, the SSB and CW, the worldwide radio, offers bandwidth choices. And when you change modes, your radio will automatically tighten up or expand the internal bandwidth filter selection. This allows you to minimize noise and maximize long-range reception. Some of your best contacts are very low wattage, and you get good distance. So, the availability of a receiver to detect weak signals is known as sensitivity. For effective HF amateur radio operation, a receiver must have a power gain of approximately, 10 million to 1, or about 70 decibels as measured by the antenna terminals, to bring in medium strength to a comfortable listening level with a set of earphones. As daunting as this task may seem, its sort of sensitivity is extremely easy to achieve with modern electronic components. Again, the difference between these type of radios versus my grandfather's big tube radios and what they said the sisters in the beginning of this.
Old anchors.
Yes, paperweights. The mixer. It's a nonlinear device that takes two signals, interjected and creates both the sums and the differences of any two radio signals. A simple diode can act as a mixer, but most modern-day radios use much more elegant arrangements, as several diodes or active devices such as transistors or FETs to create the mixer. Mixers are essential to nearly every modern radio design, and are crucial to the overall performance of radios in most cases. The capability of any radio equipment to specifically hear one frequency and discriminate against other signals on either side of the frequency is called selectivity. On VHF and UHF equipment, the selectivity is usually preset, and most equipment is plenty selective. On the worldwide radio gear, you can sometimes add more filters for increased sensitivity. While additional filters may be cut down on the fidelity of the received signal, you can tighten up on those receiver responses. AGC, or automatic gain control, formerly known as AVC, or automatic volume control, is used to somewhat level out the huge variations in the signals and can undergo between the distance station and its way to you. The AGC bus is also used in most radio to drive the S meters. Most of these radios, even the handhelds, have that little bar that'll tell you what the signal strength is. So that'll be your S meter. It can range from rudimentary to extremely sophisticated, with the values of attack time, decay time, hang time, and other parameters, all for the purpose of making HF reception most effective over widely varying conditions. don't go out and buy one. Your radio equipment already has an excellent built-in preamplifier. Only if you purchase a very old radio with noticeably weak reception, you can consider an external preamp. The preamp goes between the antenna and the input receiver. The preamp goes in between the antenna, input, and the receiver. Be careful how you wire it in. If you simply put it on the outside of the equipment, the first time you transmit, the preamp is history. It either needs external switching or must be placed inside the equipment between the antenna line and the receiver. Excuse me. Power supplies. Never try to run your 12-volt equipment directly from a battery charger or attempt to transmit your handheld with it plugged into the wall adapter. If you plan to run your equipment off commercial power with it still plugged in, always use a regulated power supply to protect your gear. Side note, if you value your equipment, I know you have a 12-volt power supply in most older equipment, computers. If you try to salvage that 12-volt power supply, it's called dirty. It's a dirty power supply. It's not regulated. This one here is about $60-80. Not bad. It'll run this box and this stuff together. So for one radio, you should be all set. But definitely get a regulated power supply. Don't use dirty supplies. It's going to cost you your radios. The regulated power supply plugs into the wall AC outlet, and then your radio plugs into the power supply. The greatest cause of handheld transmitter hum and sometimes damage. Damage to the equipment is trying to transmit with it still plugged into the AC receptacle power adapter. That's actually
We've also got now switching power supplies.
Switching power supplies.
Sometimes they can be very noisy. Sometimes you might see at a HamFest or something, somebody selling a bunch of switch mode power supplies they pulled from like a factory that closed down or something. And they will work your radio, but they do produce a lot of what's called RFI, radio frequency interference. So you could be thinking you're hearing your normal surrounding area noise, but that power supply could be injecting a lot of noise just by nature of the design of it. The older power supplies were transformers, and you had hardly any noise coming from them at all. But switching power supplies now, a lot of people will use them for mobile stations, and they can be pretty noisy.
And as you get into buying equipment, depending on the size or everything is different. Everything requires a different voltage to operate. Well, 13.8? Yeah. So 13.8 is your perfect sweet spot. So your rig is going to need X number of volts. Make sure your power supply can handle it. Don't underdrive or overdrive your power supply. Don't make it work hard because things start to heat up and they never work right.
Question, comment? What you consider 12 volts, even in your car, is actually 13.8 to 14 volts. And if you look at your instruction manual for your radios, it'll say plus or minus 10 or 15%, which brings you up to around 14 volts. What happens with a radio equipment, particularly HF radios, if you get down below somewhere around 11.8 volts, this frequency will start drifting. You'll be off frequency, either plus or minus. And it's basically only because you're not giving the radio enough food, you're not giving it enough power, enough voltage to do what it has to do.
Okay, here we go. What is a transceiver? What was that? Good. Which of the following devices is the most useful for VHF weak signal communication? Good. What type of voice mode is most often used for long distance weak signal contacts on VHF and UHF bands? You guys are for sure passing. What is the primary advantage of single sideband over FM for voice transmissions? Anybody else? but our front seated students.
Sorry.
That's all right. Keep going. We good? They have a narrower bandwidth. Which of the following is a form of amplitude modulation? Which sideband is normally used for 10 meters HF, VHF, and UHF single sideband communications? Upper. Everything is upper. Which of the following describes combining speech with RF carrier signals? Modulation. Which is the appropriate bandwidth of signals, a single sideband voice signal? 136 or 15 kilohertz? Three.
Arguably.
There is something
Yeah.
called double sideband. It's very rare, but you can actually do lower and upper together, and that 6 would be the answer for that, because 3 and 3 is 6.
Yeah. Which of the following is the appropriate receive filter bandwidth to select in order to minimize noise and interference for single sideband reception?
C.
You sure? Which of the following is true of the use of single sideband phone in the amateur band above 50 megahertz?
C.
We got a C. Anybody else? It's permitted on all of the amateur. Which of the following controls could be used if the voice pitch of a single sideband signal seems too low or high?
D.
The RIT controller. What does the term RIT mean? we are going to have that one.
Yes.
All right. Which of the following is true concerning the microphone connectors on amateur transceivers?
B. B.
I got an A, B, and a B. What is the name of the circuit that generates the signal of a desired frequency? They actually listened. Which of the following types of emissions has the narrowest bandwidth?
C.
What's the approximate maximum bandwidth required to transmit a CW signal? Amanda? What do you got? B? Ah. Which of the following is the appropriate receive filter bandwidth to select in order to minimize noise and interference for CW operation? I got an A. What's the advantage of having multiple receive bandwidth choices on a multi-mode transceiver? Permits the noise and interference detection by selecting a bandwidth matching the mode. What term describes the ability of a receiver to detect the presence of a signal?
C.
It's sensitivity. Which of the following is used to convert a radio signal from the one frequency to another?
D.
Margaritas, right? Mixer. Which term describes the ability to receiver to discriminate between multiple signals?
C.
What's the function of the automatic gain control, or the AGC? I got CA, A.
I love D though.
Yeah, go ahead. I got nothing for D.
There's no all of the above yet. Just hanging there.
Where's the RF preamplifier installed?
A.
Thank you. What device takes the output of a low-powered 28 megahertz single sideband exciter and produces a 222 megahertz output signal? That's the one. Which is a good reason to use a regulated power supply for communications equipment? And that's it. Thank you guys for joining us, and we will be back shortly.